Okay, so this is the video key for one of the versions of Quiz 4. And the first question is define what a fair game is. And a fair game is just any game whose expected value is 0. Okay, that's all you have to know. All right, the second problem is a problem where two people are betting on a pair of die that are tossed. And it says that the two die add to 2. Bill gets back his original dollar and wins 10 extra dollars. So he has a net profit of $10. Otherwise, he loses the dollar. What's the expected value? You can do this with a formula. You can do this with a table. I'm going to do it with the table. I think it's a little more clear. There are two outcomes here. He either wins or loses. There's only one way that you can get a 2 when you roll 2 die. Okay? And that's if you have 2 1s. And there's only one of those that occurs. So the probability that he wins is 1 out of 36. Therefore, the probability he loses is 35 over 36. Okay, and then we're going to go ahead and we're going to multiply this by 10 and get 10 over 36. Multiply this by minus 1 and get minus 35 over 36. And then I'm just going to go ahead and subtract them. So that's going to be minus 25 over 36. And that doesn't reduce down any further, so we have to actually compute that out. And it ends up being minus 0.644. Okay, that many dollars, or minus 69 cents. Okay, so that's that. So the expected value for one game is minus $69 or minus 69 cents. Okay. Notice that when I do the probabilities and the outcomes, I don't compute the probability of the outcome. I multiply these two. Okay. This can be a very small number, but when you multiply the two, it usually is not so small. It'll also save yourself some computational work too. Okay, so at the end, all I do is I add these as fractions. It's easy to do. And I get minus 25 over 36, and then just subtract them and round that off. Okay, so the final answer is minus 69 cents or minus $0.69. And then they want to know what is the expected value for Bill if he plays 10 games. So I'm just going to multiply the expected value for one game by 10. So he had minus 0.6944. So the final answer is going to be minus $69.44. On average, that's how much he will lose after 10 games. Okay. So whenever we have the expected value for a number of games, we just multiply the number of games, which here is 10, by the expected value for one game. Okay, and that's our final answer. Okay, on to problem 3. So here we're given some information about a health insurance policy. And it says that if they become disabled or die, they'll pay $500,000 in the case of death and $100,000 in the case of disability. And then we're told from the records of, and we said this was students, 60,000 students, 10 students have died, 25 have become disabled. What's the expected value of one annual policy for BSU? Okay, so the first thing I'm going to do is I'm going to figure out these probabilities. And so this comes from the data. I'll put these in blue. Because I'm told that from their records, 10 out of 60,000 die. Okay. And 25 out of the 60,000 have become disabled. And we're assuming that no one person became both. Okay. So this is where that probability is coming from. And I'm going to write these as fractions. Again, I'm not going to evaluate these because these will be small numbers. So I have 10 over 60,000 and 25 over 60,000. Now notice that these have to add up to 60,000. So if I add these and get 35 and subtract it from 60,000, I'm going to get 59,965. That's the probability that nothing happens to a student. Okay, out of their 60,000 students, 59,965 had neither disability or death. Okay. Now we're going to write the payoff, and this is the part we have to be careful, because when nothing happens, we're looking at it from the company's perspective. They get $500. When a person dies, okay, they pay out $500,000, but this is the part you have to remember. They still get the $500 from the premium. Okay, so altogether they lose $499,500. And notice we put a negative. That's very important. Okay. Same sort of thing here, right? They're going to lose $100,000. Make sure I did that right. Yeah. But they still gain 500. Okay, so they really lose 99,500. That's their net payout. Okay. Now the contribution is just a product from the payout and the probability. So I'm going to multiply these. Okay. And then I'm going to evaluate this numerically. Okay, because you can see these numbers are huge. This number actually here is really small. And so if you don't save the number, you can get error in rounding things off. Anyhow, when you multiply 500 times this probability, you get $499.71. Okay, I'm going to check that real quick just to make sure. Yep. It was 0.708 cents, and I rounded that off to the nearest cent. That's positive. And the other is going to be 499,500 times 10 divided by 60,000, and it's going to be negative. So when we do that, we should get minus 83.25. Okay. And finally, for the last one, we multiply this out. Minus 99,500 times 25 over 60,000. And we get this. And we're going to add these, right? So that we know that the final expected value is this plus this plus this. And notice these are negative, so we're going to be subtracting these from $499.71. And we find out the answer is $375. Okay, the answer should be positive. An insurance company is certainly not going to lose money on an insurance policy. Okay. Now, I could have asked you a second question here, which would have been, if they sell 1,000 policies, how much are they going to make? Okay, what is the expected value of 1,000 policies? And you just multiply one policy times 1,000. So it'd be 375,000. Okay, that's all for this quiz.